I am Dr. VNSR Venkateswara Rao, working as Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic of one of the important problems related to the calorific value, nothing but gross calorific value and net calorific value, which is simply abbreviated as for gross calorific value is GCV and net calorific value is simply NCV. So before starting the topic, first you see what are the contents involved in today's section. So mainly in today's topic, first we see introduction to the calorific value, nothing but gross calorific value and net calorific value. After that we see types and followed by problems. So first we see the calorific value. So what is the calorific value? Calorific value is nothing but the amount of heating value produced by the unit mass of a fuel when it undergoes combustion reaction. So what is the combustion reaction? Combustion is nothing but the fuel elements like carbon and hydrogen reacts with the atmospheric oxygen, undergoes oxidation reaction to give combustion products like carbon dioxide and water vapor. So the process is nothing but a exothermic reaction. That means what is the exothermic reaction? The reaction proceeds by the liberation of heat energy. The reaction proceeds by the liberation of heat energy. That is nothing but exothermic reaction. So our combustion reaction given the calorific value of a fuel comes under category of a exothermic reaction. That means calorific value is defined as the amount of heat produced by the combustion of unit mass or unit volume of a fuel. That means the calorific value is measured in several units. Mainly there are 4 units. One is calorie, second one is kilocalorie, third one BTU, nothing but British thermal unit. And fourth one is nothing but centigrade thermal unit, which is simply abbreviated as CHU. Centigrade heating unit, CHU. So now we see what are the types of the calorific value. There are mainly 2 types. Gross calorific value, simply abbreviated as GCV, and next one net calorific value, simply abbreviated as NCV. So what is gross calorific value and what is net calorific value? Generally, there are by taking salaries mainly considered as 2 types of the salaries. One is gross salary and second one is nothing but net salary. Gross salary means which involves the without cuttings, that may be either loans or any other etc. payments. That means gross calorific value is nothing but always the gross salary is higher than the net salary. Net salary is nothing but it involves the so many cuttings either by loans or insurance premiums. After the cuttings of each and everything, nothing but even provident fund also included in this fund, and you get net salary. So that is the difference between gross salary and net salary. Similarly, the gross calorific value is always higher than the net calorific value. Because according to the definition, the gross calorific value is nothing but after the combustion reaction, the combustion products are cooled down to room temperature. That means it is defined as the amount of heat energy produced by the combustion of unit mass, unit volume of a fuel when the combustion products are allowed to cool down to room temperature. So that is the calorific value, nothing but gross calorific value of a fuel. And next on net calorific value. So it is defined as the amount of heat energy produced by the combustion of unit mass or unit volume of a fuel, and at the same time the combustion products are cooled down to room temperature. What happens? Allowed to escape. That means they are ready to evaporating takes place. That means what are the combustion products? Water vapor. It is ready to get evaporated at room temperature. And second one, nothing but carbon dioxide. It is also gas. It is readily mixed with the surrounding air. That means escape out into the atmosphere. That means NCV does not include the latent heat of the steam or water vapor produced. Okay, so this is about the types of calorific values, both gross calorific value and net calorific value. So, and this gross calorific value and net calorific value is determined by the Joule's formula. So, one is gross calorific value and the second one is the net calorific value. That means in the formula, the calorific value, nothing but gross calorific value of a fuel is the total calorific value of each of the components. Secondly, 8 parts by the weight of the oxygen combined with 1 part of the weight of the hydrogen. So if the oxygen is present, it must be present in the combined form with the hydrogen as water, thereby decreasing the amount of hydrogen. available for the combustion by oxygen 8 parts. And the formula is given then for the gross calorific value, it is 1 by 100 into 880 into percentage of the carbon plus 34,500 into hydrogen minus oxygen by 8 plus 2,240 into sulfur, and units are calorie per gram. Generally, for each and every energy, the units are calorie, and it is measured by 1 gram of coal. That's the calorie per gram. And the second formula is nothing but NCV. NCV means net calorific value. So NCV is equal to HCV or GCV. HCV or GCV means gross calorific value into 9 into hydrogen by 100 into 587 calorie per gram. Now we see the problems. That means calculate gross and net calorific value of coal sample having the following composition. Nothing but carbon is equal to 80%, hydrogen is equal to 7%, oxygen is equal to 3%, sulfur is equal to 3.5%, and nitrogen is equal to 2%, and ash is equal to 5%. So first of all, we see the given data. Carbon is equal to 80% and hydrogen is equal to 7%, oxygen is equal to 3%, sulfur is equal to 3.5%, nitrogen is equal to 2%, and ash is equal to 5%. So for the determination of the calorific value of the fuel, the involved contents are only carbon, hydrogen, oxygen, and sulfur. We should not take care about the nitrogen and ash because they are not involved in the determination of the calorific value. That may be either higher or lower calorific value, or gross calorific value, or net calorific value. So now we see the formula GCV. That means gross calorific value is equal to 1 by 100 into 880 into carbon plus 34,500 into hydrogen minus oxygen by 8 plus 2,240 into sulfur. So this is the formula for gross calorific value. That means 1 by 100 into 880 into, what is the percentage of carbon given that 80, plus 34,500 into, what is the hydrogen 7, minus, what is the oxygen percentage 3 by 8, plus 2,240 into, what is the sulfur percentage 3.5 percentage. That means 1 by 100 into 880 into 80. We get the value nearby 6,46,400. 6,46,400 plus 34,500 into 7 minus 3 by 8, we get 2,28,562. 2,28,562.5 plus 2,240 into 3.5, we get 7,840. So these are the values, and by the combination of these three values, 6,46,400 plus 2,28,562.5 plus 7,840. Finally, we get the values that is nearby equal to 8,82,802.5. So now it is divided by 100. Finally, we get 8,828.025 calorie per gram. So this is the value of gross calorific value, nearby 8,828.025 calorie per gram. Next, we see the determination of lower calorific value. So this is the value of gross calorific value, 8,828.025 calorie per gram. Next, we see the determination of net calorific value. That means NCV. NCV is equal to GCV minus 9 into hydrogen by 100 into 587. So this is the formula GCV minus 9 into hydrogen by 100 into 587. So what is the GCV value in previous slide? 8828.025. 8828.025. 8828.025 minus 9 into hydrogen. What is the hydrogen given value? 7 by 100 into 587. So finally we get the value 8828.025 minus 9 into 7 by 100 into 587. We get the value 369.81. 369.81. So by subtracting the value of 369.81 minus 8828.025, we get the value 8458. 8458.21 calorie per gram. 8458.21 calorie per gram. So these are the values for a given mode of problem. Let us see. The gross calorific value should be equal to 8828.025 calorie per gram, and net calorific value should be equal to 8458.21 calorie per gram. Okay, so this is about the first model problem, and next is the second model problem. That is, a sample of the coal contains the following composition: carbon is equal to 84%, hydrogen is equal to 12%, oxygen is equal to 2%, sulfur is equal to 1%, and the remainder being ash. That means calculate gross and net calorific values of the fuel. That means the given contents are: carbon is equal to 80, carbon is equal to 84%, hydrogen is equal to 12%, and oxygen is equal to 2%, sulfur is equal to 1%, and remain being ash. For the determination of the calorific value, we should consider only carbon, hydrogen, oxygen, sulfur, but not the ash content. Okay, so we consider only carbon, hydrogen, oxygen, and sulfur. Now we see the formula for the gross calorific value. GCV is equal to 1 by 100 into 880 into percentage of the carbon plus 34,500 into hydrogen minus oxygen by 8 plus 2,240 into sulfur. Okay, so that means 1 by 100 into 8,080 into percentage of the carbon, A by 84%, plus 34,500 into, what is the value of hydrogen? 12 minus oxygen 2 by 8 plus 2,240 into, what is the percentage of sulfur given? 1%. Okay, so this is the substitution of given data in the Joulans formula. So that means we can get 1 by 100 into 880 into 84. 880 into 84, we get the value nearby 6,78,720 plus 34,500 minus 2 by 8, we get the value nearby 4,05,375. 4,05,375 plus 2,240 into 1, we get 2,240. That means 1 by 100 into, by the combination of these three values, we get 1 by 100 into nearby 10 lakh 86,335. 10,86,335. So that means by 100 we get 10,000. So by the combination of these three values, we can get 10,863.35 calorie per gram. Okay, 10,863.35 calorie per gram. So this is the determination of gross calorific value. Next we see net calorific value, that is NCV is equal to GCV minus 9 into hydrogen by 100 into 587. GCV minus 9 into hydrogen by 100 into 587. What is the GCV value in previous slide? 10,863.35. 10,863.35 minus 9 into hydrogen. What is the hydrogen value? 12. 12 by 100 into 587. That means 10,863.35 minus 9 into 12 by 100 into 587. We get the value 633.96. 633.96. So by subtracting this value 633.96 minus 10,863.35, we get the value 10,229.39 calorie per gram. Okay, so this is the determination of net calorific value for the given problem. Now we see for the given problem, the gross calorific value should be equal to 10,863.35 and net calorific value should be equal to 10,229.39 calorie per gram. So this is the determination of gross calorific value and net calorific value for the given model problem 2. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.